What happened in the mid-90s is physicists realized that their science wasn't really just about physics. It was about organization. It's deeper than physics in a way. They were doing applied mathematics of how systems of many interacting things develop organization and patterns and certain kinds of dynamics that you can understand. And this applies to even things like traffic flow and the way cars interact with each other, the way species interact in an ecosystem, the way people interact in a crowd. And so what inspired me was this realization that physics is kind of more than just physics, traditionally interpreted, that it applies to social systems or may apply to social systems. So that to me was very exciting. And I started thinking, this is something that more people should know about. And when I looked into some of the work in social sciences and the philosophy of social systems, I found that most of the work was kind of totally ignoring recent developments in physics. Their interpretation of ideas about dynamics and change and the typical kinds of change you should expect in the world were all based on really old physics, cycles and trends and really simple ideas. And I thought, it's a shame that they don't know about these richer concepts of patterns and dynamics coming from really new physics that could give them tools to think about change in human societies, in history, and in social patterns in a much more, I think, realistic and powerful way.
Yeah. If you had to give an overview of the book, what would be the high-level overview for the readers?
Okay, we've had this recent financial crisis that has dominated the news, and the way it's typically interpreted in economics is that the economy is kind of a stable system. It's in equilibrium, and then occasionally it gets hit by some shock, and then it's perturbed for a while, then it comes back to some new equilibrium. They think of the economy as a thing that will be in a state of balance unless it's perturbed from outside. And if you go back through history, you see the stock market has this horribly erratic ups and downs and huge crises every 10 or 15 years of one sort or another. This is true in economies around the globe. And you have to wonder, there's two possible interpretations. One is that, well, economies are these stable systems that just keep getting whacked from outside.
We just have bad luck.
Right.
Or we can blame somebody.
Right, you can blame somebody. This weird thing happened, we weren't expecting it, but that's okay now. Now it's gone back to its stable equilibrium. The alternative is to ask the question of, maybe it's not things that are hitting the system from outside, but maybe these convulsions and these upheavals and these sudden changes are part of the ordinary kind of weather of the economic system. They arise just like storms arise in the atmosphere, out of perfectly ordinary properties and dynamics of the system. If you look at economies, if you look at ecosystems, if you look at human history in a larger sense, if you look at the way electrons flow through certain solids or the way fluids flow, you find the same kind of pattern over and over again in each different setting. You find these histories that are kind of, you have these long periods of relative quiescence, which are then kind of upset by something. There's this big upheaval, and then quiet, and then upheaval. The upheavals are very hard to predict. They're scattered about in an apparently random way, and they just seem to come out of nowhere. And this kind of pattern of dynamics typifies these complex kind of systems of many interacting parts in lots of different areas. So the book is about trying to understand if there may be a more general explanation for why you see the same kind of pattern arising in totally different systems. Like traffic flow looks a bit like the dynamics you see in the stock market, and why that looks a bit like the dynamics you see in the way electrons flow through a solid or the way ecosystems behave. So I wanted to bring out in my book, how things that seem really complicated may have some underlying simplicities, and if we understand some of those simplicities, we can learn to anticipate the kinds of future we should expect. It may not be a kind of safe, comfortable future we would like. It may be highly erratic, hard to predict the next upheaval, because that's the way the system works. It has upheavals built into it and unpredictability built into it. But if that's the case, so be it. We should understand it as it is.
And accept it.
Right.
So really, the idea that instability or disruptions are natural, and we should expect them, and actually times of calmness is actually not normal in a way.
Absolutely.
It doesn't need to be stable.
And in fact, one of the best examples is, I guess, given the analogy, in the analogy sense, is the earthquake. So earthquakes, people have studied earthquakes for centuries. We still can't predict earthquakes with any degree of accuracy. Most of us think about an earthquake as the really big event that shakes the buildings. But earthquakes are going on all the time. if you had a sensitive enough device, you'd find that there are earthquakes going on right here, right now. They're just below our threshold of sensitivity. It turns out, though, that if you look into the dynamics of earthquakes, those little ones, they're just the same as the big one. They're just smaller. The kinds of things that are happening are exactly the same. It's just rocks breaking apart and sliding. It's just that really big earthquakes involves a lot more sliding along a much bigger fault than the small ones. But they're the same kinds of events. They're not qualitatively different.
If you had to take your book and you had to teach me 3 things that I was going to talk about at a cocktail party tonight, you wanted me to embrace and to say, listen, Mark Buchanan, here are the 3 points. What would the 3 points be?
Okay, I think the first is that our minds have been trained to, when we see a big event in the world, some cataclysm, a big earthquake, some kind of stock market crash, we think, well, it's such a big event, such a dramatic event, there must have been a big dramatic cause of some sort. Something terrible must have happened to the economy. Maybe somebody at some big firm, tried to trade, $100 billion worth of something, and they hit the wrong button and did the wrong thing. Mm-hmm. Something dramatic must have happened. Or when that big earthquake arises, you think, my gosh, there must have been something catastrophic that happened in the earth, totally unusual, that made that big thing happen. It turns out what science is telling us is that that's not the case. There's a radical break between cause and effect, and we need to think about cause and effect in a different way. Many systems are just configured in such a way that large events can happen at any particular moment. They start out in just the same way that the small events start out. There's nothing that you could see beforehand that would have told you that a big event was just about to happen. You could have scoured the details in as much as you want. You'd have never seen that there was something just about to happen that was going to be really big. Mm-hmm. And yet that is always possible. And why it's big has to do with an almost infinite number of details about how particular elements of the system link together, which made it possible for one thing to set off a kind of huge avalanche of cause and effect all along the chain. And so I think the first thing is we need to rethink cause and effect. And that's a very deep thing because we're not used to doing that. The second lesson, I think, is that we need to accept that the world is much more irregular and erratic and prone to disruption, continuing disruption, than we tend to think. We like to think that the world is in some sense ordered and we can live it in a comfortable way, and that the past is a sequence of periods of calm that are just broken apart by some external thing that gets in the way and disrupts things, and then things go back to normal, and there is a normal that we can count on in the long run. What I'm saying is there is no normal, that the normal is continuing a disruption. There's periods of calm broken apart by kind of burst of chaos, and then there's another bit of calm that has another burst of chaos. And the periods of calm are unpredictable in their length. How closely together the bursts of chaos happen is unpredictable. And yet this is the pattern we see over and over again. And that we think there are good theoretical reasons why many systems in nature and in human systems evolve to become just like this, mm-hmm. in order to have this kind of erratic behavior. The third take-home point, I think, is that it gets to the matter of how we can behave in such a world. If the world has this erratic pattern and irregularity built into it, it's not that it's totally unpredictable. It's a little bit predictable. We can see patterns, and we can start to act on those patterns. But they're ephemeral patterns. They're not going to last, and we're drawn into thinking they can last. And that's what often leads to big mistakes. To live in a world that is kind of poised on this boundary, it's not ordered, it's not total chaos, it's in between, it's just a little bit of pattern. To live in that world really means we need to focus on being adaptable, being resilient, being able to respond quickly, never getting ourselves stuck too much into one particular idea or one particular plan, because that's likely to be disrupted in the near future. Even though it might work out for the next 40 years, you don't know. So it's a peculiar world to try to make informed decisions and make plans, because it lives in this netherworld of predictability and unpredictability. And I think, as I say, it's a scary place to be, but it's also what makes the world fun and interesting.